All right, welcome to chapter 2, modeling distribution with data. This is probably one of the most important foundational concepts for the rest of our year. What do we mean by modeling distribution of data? Well, first we're going to start by describing the location in a distribution. For example, if I had the fifth highest score in my class and you had the fifth highest score in your class, were we the same? What do we mean by describing your location in a distribution? If we both were the fifth highest score in our class, we'd have to know how many students were in our class. For example, if I was the fifth highest in my class out of 6 students, that's not so impressive. If you were the fifth highest test score in your class out of 35 students, well, that might be a little more impressive. So rather than saying what place we came in, we're going to describe our location in a distribution by also describing the population or the sample in which we were part of. So to do this, the first thing we're going to look at is your percentile. So for example, came in fifth. I had the fifth highest score out of 6 students. You had the fifth highest score out of 30 students. So really, where were we? What was our percentile? Okay. I was, or percentile, an individual's percentile is the percent of the values in the distribution that are less than yours. If I had the fifth highest score, there was one less than mine. So my percentile would be roughly 17%. Now, if yours was, there were 25 students less than you. So you were roughly the 83rd percentile. So percentile is where do you stand relative to everybody in your distribution? We have an example here of 25 students who are taking a test that's out of 50 points. So if I told you you got a score of 43 on your test, would you be happy? Well, it depends on how many other students took the test, and it also depends on what the test was out of. So the example we're going to be using for the next several problems will be this data set right here, where 25 students in an AP Stats course took a 50-point quiz. So for example here, the student marked in red got a 43. Well, if we look at the dot plot, we can see where their relative standing was compared to everybody else. Now remember, percentile is the percent of the values in a distribution that are less than your score. So if you are this red dot right here, and you wanted to count how many students were less than your score, that would be 20. So 20 out of 25, we would say that you are not in the 80th percentile, but you are at the 80th percentile. So it's simple. Write your fraction, turn it into a percentage. That's how we would describe percentile, measuring your location using a percentile. All right. Now, as you can see here, we have percentiles, counts, frequencies. As we discussed in chapter 1, we have a frequency table, which you can see right up here. We have, which is just strictly a count. This is a data set of the age at which our presidents were, at the age presidents were at inauguration. So you can see we had 2 presidents that were between 40 and 44 when they were elected, 7 between 45 and 49. Again, frequency is strictly a count. Relative, remember, anytime we see this word relative, we are talking about percent. Okay? So relative frequency tells us what percent of the presidents were between the ages of 40 and 44. Cumulative frequency is just an count. So where did this 22 right here come from? It came from 2 plus 7 plus 13. It's the cumulative frequency of all of the presidents up to the age of 54. This last column is something new that we haven't looked at yet. It's called the cumulative relative frequency. Okay. Remember, cumulative is an accumulation of everything that came before, and relative means percent. So as you can see here, there were 4.4% of our presidents between the ages of 40 and 44. Well, why is this number 20%? Because it's an accumulation of the percentage of presidents all the way up to the age of 49. So this 20% right here came from the 4.4 plus the 15.6. And this will continue all the way through. Why do we have 48.9 next? Because it was an accumulation, cumulative, of 4.4, 15.6, and 28.9. Next, we're going to describe a cumulative relative frequency graph. I know that's a lot of words. They used to call this ogive. Okay, that was the name of this kind of graph. Notice that it's always a step ladder effect. It's always going to increase from left to right. And the first dot will always be at 0%, and the last dot will always be at 100%. And you can see if you go straight across here, even though my line's not very straight, you can see that that final dot is at 100%, and that matches the 100% that we see here on the cumulative relative frequency chart. All we're doing is plotting these points here and then connecting them with a line in between. So this is an example of the cumulative relative frequency graph. So we may be asked, half of all presidents are less than what age? Well, 50%, that would be half. So we would go across and then draw a line straight down and say, oh, well, that looks to be about approximately 54. So we would say approximately half of all of our presidents were 54 or younger at the time of inauguration. So remember, frequency, simply how many times did it show up? Relative frequency, what's the percent of those times that it showed up? Cumulative frequency is a sum of the frequencies, and relative cumulative frequency is the sum of the percentages of those frequencies. All right. Next, we're going to take a look at standardized z-scores. Okay. Now, this is probably going to be the calculation that you're going to make the most of any calculation that we do this year. You're going to find more z-scores than anything else. Really, what a z-score is doing is it's another way for us to measure location. Okay? Just like your percentile, oh, I'm at the 80th percentile, that means that 80% of all the observations are less than mine. If we relate it to the test score problem, 80% of all the test scores were less than mine. Now, for a standardized z-score, it's another way to explain your location or your relative standing, or how do you compare relative to everybody else. And like we talked about at the beginning, if you say you came in 5th place, it has very little meaning if we don't know 5th out of how many. So a z-score is pretty simple. I'll write this for us in notation. So the value X, that's you. What is the score, or the person that we're looking at? In this case, that would be your score, minus the mean score of the data set divided by the standard deviation of the data set. Later, we'll see that this z-score is going to be written as X minus mu over sigma. Like we spoke before, X bar describes a sample mean. S is the sample standard deviation. Sample mean, sample standard deviation. Mu is the mean of the entire population, and sigma is the standard deviation of the entire population. Either way, the z-score is going to be your value, or the score we're trying to find out about, minus the mean divided by the standard deviation. So it's another way to talk about relative standing or your location. Okay. A z-score is simply the number of standard deviations you are away from the mean. How many standard deviations are you away from the mean? We will get more into z-scores coming up very shortly here in chapter 2.